So interference is what occurs when two waves of light interact. Okay, so for the purpose of this, I've drawn two wavelengths of light, one on top of the other. Right, they have the same wavelength. I've just offset them a bit. Okay, just for this, just for the demonstration. So to begin this, right, let's notice the relative positions of the peaks and the troughs for these two wavelengths of light. Okay, so we have a peak here, and that is in the same position as the peak in the light wave in the bottom. And similarly, right, the troughs are in similar positions. Okay, so these, because again they have the same wavelength and the peak and the trough positions are in the same place, we say that these two waves are in phase with each other. Okay. Right. And so, by contrast, right, on the other side of the board here, we have two waves, which we've written again on top of each other, one on top of the other, right, where the peak, right, of the top wave, right, corresponds to the trough of the second wave. Okay, and then over here, right, we see that the trough of the top wave is in the same position as the peak of the bottom wave. Okay, and so these, we would say, are out of phase. Again, we are saying that the wavelengths for each of these two waves is identical. All right, so now let's say we move these axes, right, which these waves are centered around, into the same position. So we're just going to move, imagine for a second, if you will, that we're moving this wave on the bottom into the exact same axis that we have for the wave on the top. What would happen? The two waves would interact. And in this case, because the waves are in phase, we would have what's called constructive interference. There we go. Constructive interference. And in constructive interference, right, the amplitudes add. Okay, so let's say if we gave this a value of 1, we say the peak adds to the peak here, right? And so if both of these peaks, for instance, have an amplitude of 1, the peak of adding these two waves together is going to be 2, right? So that means the amplitude, the peak height, right, the amplitude of the peak is going to be twice as large, right, as each of these component peaks, right? And so these add together. And so similar with the trough, right, if we give the value of the amplitude of the trough here as -1, and this one is -1 as well, right, then what we expect when we add these together is we're going to have a trough with an amplitude of -2. And so, again, because these are in phase, right, what we end up with is a wave with a wavelength lambda, exactly like the two waves above, but with twice the amplitude. Okay, again, this would be called constructive interference. Right. For the two waves that are out of phase, right, the opposite is going to happen, and what we're going to get is called destructive interference. All right. And so again, if we give this amplitude, right, this peak and amplitude of +1, which corresponds in position to the trough of the wave on the bottom, which we're going to give an amplitude of -1, when we add those together, we're going to get 0. And what's actually going to happen, again, because these are the same wavelength, these are out of phase, what's going to happen is when you add those two waves together, you're going to get no wave at all. You're just going to get a straight line. Those amplitudes are going to completely cancel each other out. And so the wave that you get is basically not going to have any amplitude anywhere. It's going to be 0 everywhere. And that is why we call that destructive interference, because it destroys the amplitude of the wave.